Kristen Atchison here, and we are talking about the chapter on threats to internal validity and null effects. And this is the first part of that chapter that we're going to talk about. We're going to focus on internal validity, and we'll have another lecture that will focus on finishing up internal validity and then null effects. Okay, so we have a really bad experiment. Now, not quite as bad as our goldfish cracker experiment, but still pretty bad. And what we have here is we have the pre-test, post-test design. And it could be anything. And what you do is you test somebody before the treatment, you test a group of people before the treatment, you measure them, you test a group of people after the treatment, you measure them. And in both of these situations, whether we're looking at rambunctious behavior or whether we're looking at depression scores, it looks like the treatment helped. Whether it was the sugar-free diet, whether it was the therapy on depression score, it looks like the treatment helped. Great, done, right? All wrapped up. But the problem is, did the independent variable really cause that difference? Was it the sugar-free diet? Was it the therapy that caused the experiment? And the problem is there are 6 potential threats to internal validity in this one group pre-test, post-test design. There are 3 potential internal validity threats in any experiment. So we're up to 9 now. So with so many threats, are these still useful? We'll also talk about another 3 effects as well. So we have the dirty dozen, your book calls it, of internal validity threats. We have already talked about design confounds, selection effects, and order effects, and how we control for those and balance those so that they don't influence our internal validity. We're going to do the same thing now with these 6 in the middle: maturation, history, regression to the mean, attrition, testing, and instrumentation. And in the next lecture, we'll go over observer bias, demand characteristics, and placebo effects. So right now, we're going to focus on these 6 threats to internal validity that are an issue in pre-post test designs. So these happen when we have confounds from environmental factors, environmental variables. This can be the time of day, this can be different rooms, and we control them just like we do in any other between subjects design. We balance them or we hold them constant. We can also have these confounds from time-related factors: history, maturation, instrumentation, testing, and statistical regression. And these are ones that are going to be issues in these pre-post tests within subjects designs. These are within subjects designs because we're measuring the person twice, right? We're measuring the group of people twice, pre-test and post-test. And these time-related factors are really issues in this pre-post test design. So we'll talk about which each of them are, and we'll talk about how to fix them. The confounds from the environmental factors we've already talked about. We talked about that with design confounds, and those are held constant or balanced and within subject design just like they are in those between subject design. But these time-related factors are a little bit different, and we'll talk about each of them in more detail. So the first one we're going to talk about is history. History is when there's an event that occurs at the same time and changes participants' behavior. There's something in the participants' history that includes events other than the treatment, okay? And this can be any kind of event that's happening to the group or to the individuals that's affecting this. It's something else that's being allowed to co-vary with that independent variable, okay? So it's being allowed to co-vary with them, and so we don't know if the changes are due to our manipulation of the independent variable or if it's due to this effect of history. And so it becomes difficult to distinguish whether a treatment has an effect. So an example of this is you're doing a study on a treatment or a therapy group to reduce risky sexual behaviors, including unprotected sex, including sex with people that you don't know, these kinds of things. They're doing a study, they're doing a treatment, a support group to kind of reduce these risky sexual behaviors. Great. We take a pretest on how many people are engaging in risky sexual behaviors. We take a post-test, and that number's gone down. Yay, the therapy worked. But we don't know that because history. It could be that either at about the same time that our study began, sometime after the pretest, a big celebrity came out as HIV positive, or came out with a sexually transmitted disease, or came out and said something that said, hey, I engaged in risky sexual behaviors and bad things happened to me. And this was highly publicized and it was everywhere. Well, then our post-test, do we know that it's our treatment group that caused this decrease in risky sexual behaviors? Or could it be this celebrity that came out? Could it be seeing this happen to somebody else in a very public way that affected it? We don't know. And that's why history is a threat to internal validity. Another threat to internal validity is maturation. This is the idea that participants just naturally change over time. We mature, right? So as a developmental psychologist, I have that lifespan perspective that development is conception to death. None of us are done, and we're all changing all of the time. And that's what this maturation risk to internal validity is saying. It's saying that these maturational changes, not the treatment, may explain any changes in a participant during an experiment, okay? So let's think back to our risky sexual behaviors. Maybe we started this study with at the beginning of the school year with college freshmen. They're brand new to the campus, their parents aren't watching them, and they think, hey, I've got this freedom now. And that's when we do our pretest, okay? We do our post-test at the end of their senior year, okay? And we see a decrease in risky sexual behaviors. Well, maybe it's our test happened. Maybe it's just that these people changed over time. They went from not knowing anybody, so they were engaging in more risky sexual behaviors, having sex with people that they didn't know, to being more likely in a committed relationship. Maybe that's the changes, those maturational changes, that we just change over time, that people matured and they make better decisions. That's what a maturation change looks like. So then we don't know it's the treatment, or do we know it's just the natural changes within this population? This is at a greater risk for developmental research, especially the younger the participants are, because change is more rapid when you're younger. We'll still see change in all age groups, but this is going to be a greater risk in these periods where developmental change is happening more rapidly, where this maturation is happening more rapidly. Another threat to internal validity we have is regression to the mean. Regression to the mean is that sometimes you get a really high score and sometimes you just get a really low score, and these are chance factors, right? So you didn't really study for a test and you took the test and somehow you managed a really, really high score. And you studied for the test and you didn't do very well and you just managed a really, really low score, and it was chance, right? It had no reflection of how well you studied. Well, on the next time you take the test, those chance factors aren't likely to be present. And so your score will not be so extreme. Your score, or the scores, will regress or go back towards the average, towards the mean. Very rarely do you see extreme scores repeatedly. So if you have pretest scores and they're really, really high, it's more likely that they're going to go closer to an average, closer to a mean. And so then when we look at our post-test scores and they're lower, as we did at those two first examples, is it our manipulation of the independent variable, or is it just that we had extreme scores to begin with, and these have regressed towards the mean? And so this is accounting for the participants' changes over time, and it's not the treatment at all. It's just that we started out with really extreme scores, whether they're extremely low or extremely high. If you have really, really high scores, they don't have any place to go but down. If you have really, really low scores, they don't have any place to go but up. And so it may not be your treatment effect. It may be this regression towards the mean. Another one we talk about is subject loss. This is also called attrition, and we talked about it a little bit already, but this occurs when participants fail to complete an experiment. Now, the problem is we start out with equivalent groups, right? We did our random assignment. We made sure everything was really equitable. And so we have these equal groups. We have a really representative group at our pretest, but people drop out over the course of the study. And so at the end of the study, our group is no longer representative. Our group may no longer have that same random assignment. So we're doing a study on exercise maybe, right? And we start out and we have a really representative sample, and it has a big range on people's typical exercise behavior. It has a big range on weight. It has a big range on health. It has a big range on age. It has a big range on all of these things, right? It's very, very representative of the general population as a whole. And our study is over the course of 6 weeks, you're going to go to the gym for an hour a day for all of these people. So this includes the older people. This includes the people that haven't exercised a lot. This includes the overweight people. Everybody is going to go to the gym an hour a week. This is our exercise program. This is what we're testing to see if it has an effect on mental health scores, okay? We're seeing, is exercise related to mental health scores? And at the end of the study, we see an improvement in mental health scores. Everybody's way healthier. But is it really that the exercise helped, or is it that we had this subject loss? The people at the end of the study may not be all the people that started the study. Maybe we lost the older population. Maybe we lost the people that didn't exercise a lot. So at the end of the study, who we're left with are the people that just exercise a lot anyways. We're not left with a really representative population. And so we don't know then, is it our independent variable that's causing that change, or is it this our subject loss, this attrition? Now, there's two types of attrition. There's mechanical subject loss, and there's selective subject loss. Mechanical subject loss is okay, because it's going to be pretty balanced. And selective subject loss is where we have a problem, because this is where it's going to mess with our equivalency of our pretest and our post-test groups. And we're going to talk about that in a little bit more detail. So mechanical subject loss is when there's equipment failure or experimental error or something that influences a participant's ability to complete the experiment. So in my research, the way it's set up is infants come to a lab, they sit on their parents' lap, and we show them pictures on a computer screen, and we record how long they look at it. Sounds great, unless the computer's not working, because it's got this multiple monitor situation, and this is a computer program that's designed for developmental researchers. It's not got a lot of tech in it, okay? It's not super user-friendly. So if it's not working, it's really hard to get it to work. It's really hard to get everything set back up and all the monitors working in the way that they're supposed to do. So if you're running an infant through your experiment and the computer just decides it's done, that would be mechanical subject loss, okay? Now, this is often, again, due to chance factors. It's not due to the fact that Bobby Sue didn't want to participate. It's due to the fact that the computer didn't want to participate. And so this is likely to occur equally across conditions of the experiment. This is likely to occur equally in the pretest versus the post-test. And so we're going to have those still equal groups. They're not going to be self-selecting any group member based on particular characteristics. It's going to be fairly easy. Because of this mechanical subject loss is due to chance, it does not threaten the internal validity of the experiment. It's still not great, still super frustrating, everybody's upset, but it's not going to influence that internal validity because it's due to these chance factors that are going to happen equitably between these groups, between your post-test and your pretest and your post-test group. Now, selective subject loss is a different matter. This occurs when participants are lost differentially across conditions. So when I was talking about our experiment study, and I was talking about how all of our older adults dropped out, how all of our low exercise groups dropped out, that is a problem. Some characteristic of the participant is responsible for the loss. And this is where the issue comes in. Something about that participant, some characteristic of them that is typically related to the dependent variable. That's a problem, right? Maybe it's just we were looking at mental health scores. Maybe the people weren't exercising a lot because they had higher depression scores to begin with. Maybe that's why they dropped out. They were depressed. They didn't want to exercise. Well, it's going to look like that exercise fixes depression. Well, no, all of our depressed people dropped out. So when we have this, especially when this subject characteristic is related to the dependent variable, it's a huge threat to internal validity, this attrition, the selective subject loss. This can include, again, a group of depression is compared to a non-treatment control condition. The depression people are more likely to drop out than the non-depression people, right? Because that's one of the symptoms of depression, is not wanting to go and do and engage in things, right? And so we could see a selective subject loss there. People could sometimes drop out of a control condition more than a treatment condition as well. For other things, if you're sick and you're getting a medication that you think might work, you want the medication, right? Or you want the treatment, you want the therapy, you want those things. Again, this is a problem when our pre and our post tests are different. So when we have different people in our pre-test than our post-test, and these have been lost due to the subject's selective characteristics, we have a problem. We can also have testing effects. Testing effects is, again, that effect of taking the test over and over again. So you take the test, the pre-test, and then you take the same test in the post-test. Well, you just might be better at taking the test, right? You may be more familiar with the measures. You may understand it better. And so you take that test better. So we don't know if it's our treatment that helped or the fact that you're more familiar with the measure the second time. And so again, this testing is an issue of internal validity as well. We can also have problems with instrumentation. We use the instruments to measure people's performance over time. Those instruments can change over time. So if we have an observer that's recording behavior, they could become bored and not be paying attention to the same kinds of things at the end of the study that they were at the beginning of the study. They can become tired. They can become bored. We can have also the reverse happen. We can have observers become better at observing over time. And then that's a problem. They're better able to detect those things that we're looking for at the end of the study than they were at the beginning of the study. We can have problems with a physical instrument. If you're measuring your dependent variable's weight, your battery in your scale died or is dying over the course of the study. So the weights at the end of the study aren't as accurate as the weights at the beginning of the study. We can have those problems with instrumentation. And these changes in participants' performance may be due to the changes in the instruments and not to the treatment. So the problem with all of these is now we don't know what's happening. We don't know what is affecting that change on that dependent variable. Is it our independent variable or is it instrumentation? Is it testing? Is it attrition? Is it maturation? Is it history? Is it one of these things that's going on that's affecting this outcome? The way we solve for this is we add a comparison group. And all that is another group of people that we test pre-test and we test post-test. They just don't get whatever that therapy is in between. And because they're getting the pre-test and the post-test just the same, they're getting the exact same time-related factors, they're just not getting the independent variable, then we're able to compare whether our independent variable caused change. So all we have to do is add a second group that doesn't get that treatment, that doesn't get that sexual education risky behaviors treatment, that doesn't get the exercise group, that doesn't get these other things, to look at whether these effects of instrumentation, attrition, testing, history, any of these caused a problem. So these 6 are cured, all solved by simply adding a comparison group that gets both the pre and the post-test. So it's not that pre-post-test studies are bad. One group pre-post-test studies are bad. When we have one group that doesn't have a comparison, that's where we have the issue. That ends our discussion about these threats to internal validity. Check back. We've got another video that's addressing internal validity risks, and we'll discuss null effects as well. Thanks.